Hi, my name is Robert Schumann, and in this video I'm going to go through what SVR actually looks like on the wire. So specifically, what I'm going to show is a really simple overview. Just going to look at a single session, just looking at client to server in two SSR routers. So I have a client and a server. These are actually Paragon Active Assurance test agents. So I'm generating some traffic with a specific source and destination port so I can easily identify it. And then I have an ingress and egress router. And on my ingress router, I'm going to be capturing this session in question. And we have some addresses that are going to be used for all these different devices. So the client is going to be using a 100.203 address, the server a 192.168.10.152 address, and then I have my waypoint addresses for my ingress and egress routers that they use to communicate with each other. And so from a packet standpoint and a session standpoint, what's going to happen is Paragon's going to create a session, right, a test session. So the client creates a TCP SYN. He sources from a source port of 5678 to a dest port of 5000. When it arrives at the ingress router, that router then says, all right, what's the source tenant, the destination service, the associated policies that need to be applied, the fib, right? What's my next hop? Does this session need to be written to disk as part of a session capture, which on that router we had that set to true, and that's where the packets that I'm going to show in a second came from. And so now what it's going to do, once it identifies that it's allowed to transport the session, is it's going to create a secure vector router session between the ingress and egress routers. So the ingress router picks a ephemeral port pair, and so in this case it picked a source of 16552 to a dest of 16889. Now, if it sends those packets as part of that new session to the egress router, it's going to have no idea what that's related to unless we convey some metadata. So this metadata is added to the payload portion of the packet, and I'll show what that looks like in a second. And it's going to contain all the context details, right? So what's the original source tenant, the destination service, all that good stuff. That egress router processes that data and then figures out, all right, where does this need to go? It needs to go to the server. So it takes that payload data and the metadata, reconstitutes the packet, right? So we transported that data in UDP, but we're putting it now back into TCP, put everything back to the way it was originally, and then that server sends its response, in this case, a TCP SYN-ACK. That TCP SYN-ACK gets transformed into UDP, and then with the source dest ports that are used prior. And then we were also going to add a little bit of metadata to this response packet to acknowledge it. And then that packet is sent on its way. So that SYN-ACK goes on towards the client. And then the rest of the session just proceeds from there. So when we see additional data as part of the session, it's just going to be on those first two packets between the ingress and egress SSR routers. So let's take a look at this on the wire. So here's my session capture, and I've colorized this so hopefully it's a little bit easier to see. All the TCP packets are pink, all the UDP packets, which is the SVR, are green. And so here's my SYN packet that came into the ingress SSR, right? And then it left the ingress SSR, right? So we're now going from the source waypoint to the dest waypoint. We have our new source dest UDP ports, and it went from 74 bytes to 305. And what's actually in there is the metadata, which starts with a value of 4 Charlie. We can see we have our tenant, in this case was called Red Edge. I have my Paragon testing.core service, that's the service name. I have the router that it came from, so Red Edge, the security policy for internal, the IP address of that waypoint, so if the traffic's natted, we know where it really came from. We have the context details for the application. So what actual application was this? And then we have the call out here to actually perform the session capture and write the traffic to a PCAP file using the file name of specific port. And that's how this was created over here. And so that packet goes on. So the SYN goes to the server. The server then sends its SYN-ACK. The SYN-ACK is transported in that UDP session from the egress router to the ingress router. And then the ingress router sends that SYN-ACK onto the client. So we have our metadata that's here, right? So that metadata, so we have 165 bytes, then goes down to the original size, which is 74. And this is where our metadata is in these two packets. And then from here, that packet size is going to be consistent, right? So now we have the client sending an ACK back, right? And you can see it left the ingress SSR router at the exact same size, right? So all the other packets are uniform in terms of their size as it comes into an SSR and leaves, because we're not having to add any additional overhead. We're not encapsulating the full packet. We're using secure vector routing to do this.